From today, I am starting a new chapter in classical mechanics, and this is motion in rotating frame. Actually, this chapter is an elementary chapter of classical mechanics, but it is in the syllabus of BSc first semester, also in BSc third part of several universities of India, and in first semester of MSc 2. So this is a very important chapter, and different students of different classes of physics need this concept of motion in rotating frame. So several viewers of my channel are demanding uh, that to produce videos on motion in rotating frame. So thinking about this demand, I have started this chapter on motion in rotating frame. This first video on motion in rotating frame is not related to motion in rotating frame, but here I am just going to introduce you the very elementary concept of reference frame or frame of reference. Definitely you have studied this reference frame in your lower classes of physics, but I am just revising your concept because this will need to study this very important chapter, motion in rotating frame. Actually, the concept of frame of reference is based on the validity of Newton's first law of motion. You know, Newton's first law of motion is also known as law of inertia because we get the concept of inertia or mass from Newton's first law of motion. So I would like to introduce you Newton's first law of motion at first, and then we will discuss the reference frame. You will be surprised that why I am saying that I will introduce you Newton's first law of motion, because this is a very elementary concept and you study Newton's laws of motion from your very lower classes. But here you will find that I am just formulating Newton's first law of motion in a mathematical way with the help of Newton's second law of motion, because I know you all know about all the three laws of motion. So it is not inconvenient for you if I am talking about the Newton's second law, and in terms of Newton's second law I would like to introduce you Newton's first law because you already know Newton's second law. So the aim of this introduction on Newton's first law of motion is only to introduce you how we can learn about the Newton's first law of motion in a mathematical way, in a very brief and concise way in terms of the Newton's second law. So I am actually introducing you with this law of inertia in terms of the Newton's second law of motion. You know that the traditional or conventional statement of Newton's first law is what? Definitely you have this statement in your mind. Actually, the conventional statement of Newton's first law of motion says that a body continues in its state of rest or in motion with constant velocity unless not acted upon by unbalanced external force. It means a body will remain at rest and it will continue its motion with constant velocity until we apply a net external force on the body. This is actually the conventional statement of Newton's first law of motion. So you can think that if the body is free from force, or you can say we consider a force-free body, then there will be only two states of motion. First one will be rest, that body will not move, and another will be the body moving with constant velocity. Okay, And when you say velocity is constant, since velocity is vector, it means its magnitude and direction both are constant. So in this condition, the body can move along a straight line only. So Newton's first law of motion talk about the rectilinear motion with constant speed. Okay. Now, to understand Newton's first law of motion in terms of second law of motion, let us consider these two situations. You know that Newton's second law of motion is what? Definitely you have the statement of Newton's second law in your mind. In brief, we simply say that according to Newton's second law of motion, the net external force F acting on a particle or on a body or on a system is simply equal to rate of change of momentum. Here I have written this momentum two times, so you should read only momentum. Rate of change of momentum of the particle or of the body. When you say rate of change of momentum, what does it mean? It means change in momentum per second. That will be equal to the net external force acting on the particle. In a mathematical way, we can say that if a particle is in motion and at any time t, let us say the particle is moving with velocity v and its mass is m, then its momentum will be mv. So you can say that at any time t, the momentum of the particle or the system is mv. Then, according to Newton's second law of motion, what will be the net external force on it? Since it is equal to rate of change in momentum, so in terms of calculus, you can write F equal to dp by dt. Okay, this is rate of change in linear momentum. When you say momentum, that means linear momentum. But you know, momentum is equal to mv, and in Newtonian mechanics, you know that mass is a constant. It does not depend on time or velocity. So this m will be outside of this differential operator, and so F will be equal to m times dv by dt. But what is this dv by dt? You know, dv by dt means rate of change in velocity, and rate of change in velocity, you know, it is called acceleration. So instead of dv by dt, you may write a. So finally, you say that according to Newton's second law of motion, F is equal to ma. And this formula you already know, I hope. Now let us consider that the force acting on the particle is zero. It means we are considering a situation when no net external force acts on our system or on our body or on our particle. So when F is zero, then according to this equation 1, you can say that ma will be equal to 0. Okay? But when you talk about Newtonian mechanics, then definitely you should know that mass of the particle cannot be 0. Because in Newtonian mechanics, whenever you say a particle, definitely the particle is associated with mass. Because Newtonian mechanics does not talk about massless particle. Although in quantum mechanics, you consider a particle having zero rest mass, like photon. But in Newtonian mechanics, particle means massive particle. You never talk about massless particle in Newtonian mechanics. So definitely this m is not equal to 0 because we are talking about Newtonian mechanics. But the product of m and a is equal to 0, and we know that m is not 0, so certainly a will be 0. So what you have learnt? If you consider that the net force acting on a particle is 0, then its acceleration will be definitely 0. So you can write this condition in this manner which I have written inside this box. A is equal to 0, it means acceleration is 0, if F is equal to 0. You know, this if, I double F if means what? It means if and only if and only if, that is, it is for the necessary, it is written for the necessary and sufficient condition. So you can say that A is equal to 0 if F is equal to 0. In fact, this is Newton's first law of motion. Now, whenever anybody asks to you what is Newton's first law of motion, never say that conventional statement. You can say in brief that according to Newton's first law of motion, A is equal to 0 if F is equal to 0. Actually, all the facts in that conventional statement are hidden in this very brief statement. All the facts. Okay. So I have written here that this statement written inside this rectangular box is the Newton's first law of motion or law of inertia. When you say A is equal to 0 if F equal to 0, what does it mean? It means that according to Newton's first law of motion, the necessary and the sufficient condition for unaccelerated motion, that is for acceleration to be 0, is what? The condition is the net force acting on the system must be equal to 0. And in other words, you can say that force-free motion is unaccelerated motion. This is actually the Newton's first law of motion. So in a mathematical way and in very brief, you can write Newton's first law of motion according to this statement: A equal to 0 if F equal to 0. This is Newton's first law of motion. Okay. Now we can cast this statement in terms of velocity too. Let us see. As you have seen that according to Newton's first law of motion, A is equal to 0 if F is equal to 0. But you know that A is defined by dV by dt. So you can say that dV by dt is 0 if F is equal to 0. But you know that if differential coefficient or derivative of a function is 0, then according to calculus, that function must be a constant. So since dV by dt is 0, so V will be constant. So we can say that V is equal to constant if F is equal to 0. And this is another form of Newton's first law of motion. Although these two statements are not different. When you say A equal to 0, that means V equal to constant. Okay. So I have only written this fact in different way. It is not different fact. Both statements are same. When you say A equal to 0 if F equal to 0, and when you say V equal to constant if F equal to 0, these are not two different statements. These are equivalent to one another, because we know when velocity is constant, acceleration is certainly 0. So both of the statements are same. But you can state Newton's first law of motion in this way too, that you should say according to Newton's first law of motion, velocity v of a system or body or particle is constant if F is equal to 0. Now you know, when you say v equal to constant, what does it mean? It means v may be 0, because 0 is also a constant. And when this v will be 0, we simply say that our body is at rest. But this constant may not be 0, it may be some another constant. Let us say v is equal to 10 meter per second towards east. That is also a constant. So v will be either 0 or any other constant. And when v is any other constant, it means our body is moving along a straight line with constant speed. Or you can say that v equal to a non-zero constant, that means uniform rectilinear motion. So Newton's first law of motion talk about uniform rectilinear motion. Uniform motion is also possible on another path. You have definitely studied uniform circular motion, during which the particle moves with a constant speed along a straight line. But velocity in that case is not constant. Here velocity is constant, which means both magnitude and direction should be constant. And magnitude may be constant when the particle will move on any path, but direction will remain constant only when the motion is along a straight line in a particular direction. So you can say that when no force acts on a particle, the particle is either at rest or it is in motion with constant speed along a straight line. This is Newton's first law of motion. Okay? Or you can say that the force free motion of a particle is a uniform rectilinear motion. So this was all about the Newton's first law of motion. Definitely you will be happy after this video, because definitely you have learned something more for Newton's first law of motion. Okay. Now, after getting the idea of Newton's first law of motion, now I am giving you the concept of frame of reference or reference frame, because our prime aims to discuss or to introduce you a frame of reference in this video. But that will need the concept of Newton's first law of motion. So I have introduced first of all to you with the Newton's first law of motion. Now this idea of frame of reference is also very elementary. You have definitely studied in your lower classes. So I have previously said to you that this is just a revision for you to learn about the motion in a rotating frame. Okay. Now, what is this frame of reference? Actually, frame of reference, motion is a relative concept. Whenever you talk about state of motion of a particle, it means you have to describe, you have to state the different parameters which actually measures the state of motion of a particle. And what are those parameters? Those parameters which determine the state of motion, that are position of the particle, velocity of the particle, acceleration of the particle. These are actually different parameters in terms of which we describe the state of motion of a particle. And all these quantities depend on the fact that relative to which another body you are defining those things. So we need the concept of frame of reference to deal with the state of motion of any body. And that's why frame of reference is defined as a coordinate system attached to a rigid body or fixed in a space, relative to which the state of motion of any another body is described. Let us see here that there is a body, let us say B. This is a rigid body. Okay. And taking any point on this rigid body fixed, let us say O, as origin, here we construct a three rectangular coordinate axes. These are OX, OY and OZ. Okay. And we consider this coordinate system as a reference frame. And now let us consider that there is a particle which is in motion, and during its motion at any time t, it is located at this point P. And then the position vector of this particle with respect to origin of this coordinate system is r. So you can find this r or this position coordinate with respect to this origin. And that's why we can say that we can describe the state of motion of this particle when we know this position vector r with respect to some reference frame. If you know r, you know that we can define its velocity, because v is equal to dr by dt. So knowing r with respect to s, this s has been named by, this s is just a name of this frame of reference. For convenience, we write some symbol for the reference frame. And once you know r, you can find v, and if you know v, you can find its acceleration, and that acceleration will be dv by dt. And you know that this r, this v and this a, these are the parameters to describe the state of motion. So knowing or we can easily find B and A. It means you can easily find all the parameters of motion with respect to this reference frame S. Okay, so reference frame is nothing, it is simply a coordinate system attached to any body, a rigid body, with respect to which we describe the state of motion of a particle. Okay, now actually this reference frame is of two types. The first one is called inertial frame and the another is called non-inertial frame. Okay, now what are these inertial frames and non-inertial frame, we will discuss in very detail here. This name inertial frame has been drawn from the first law of Newton's first law of motion, which is also called law of inertia. Since the first law of motion is called law of inertia, so this frame is called inertial frame. Why? Why it is called inertial frame? Because this inertial frame is defined in terms of the validity of Newton's first law of motion. In fact, all those reference frame in which Newton's first law of motion, which is also called law of inertia, hold good, those frames are called inertial frames. It means Newton's first law of motion is valid in a frame, and if it is valid in a frame, it means that frame is an inertial frame. So in nutshell, you can say that inertial frame is such a frame in which Newton's first law of motion is valid, it holds. And when you say Newton's first law of motion is valid, what does it mean? You have just seen that according to Newton's first law of motion, acceleration of the body will be zero if net force acting on the body is zero. So if such a phenomenon or such an event takes place in a frame, then you can call that frame in an inertial frame. It means you have to see that if we consider a force-free body and you measure the acceleration of that force-free body relative to a frame, and if your answer is zero, you find that the acceleration measured with respect to a frame of a body on which the net force is zero is equal to zero, then you can say that in that frame Newton's first law of motion is valid, and such a frame is called an inertial frame. Okay, so you have to see, or you have to take a force-free body, okay, and then you have to measure its acceleration with respect to some frame, and if your result is zero, it means acceleration is found to be zero, then you must say that the frame under consideration is an inertial frame. Okay, I hope you have understand. Now we will actually see here some of the important properties of this inertial frame. Actually, acceleration of all inertial frames are zero. So you can simply say that inertial frames are unaccelerated frames. These frames are not accelerated frames, these are in motion but with constant velocity, not with acceleration. So I have written here that these frames move with constant velocity, or it may be at rest. So all frames which are either at rest or in motion with constant velocity, those frames are actually inertial frames. Only those frames. Okay. So you can say that its motion can be only rectilinear because v equal to constant, it is possible only on a rectilinear path. So definitely whenever you talk about an inertial frame and the frame is in motion, definitely its motion will be rectilinear. So you can easily say that any rotating frame is never an inertial frame. Our chapter is motion in rotating frame, but that rotating frame will be never an inertial frame. That will be actually a non-inertial frame. You will see later. Okay. So I think you have understand what is this inertial frame. Now, an inertial frame is not unique. You cannot say that in this universe there is only one frame which is inertial and no other frame is inertial. It is not a fact. Actually, if you know an inertial frame, then you can easily find the other frames are inertial or not inertial. You can easily check. For this, let us consider that this S is an inertial frame. This unprimed frame S is an inertial frame. We assume it. And this frame S dashed, which is in motion, is an unknown frame. It means we do not know that this S dashed is either an inertial frame or a non-inertial frame. We do not know. We have to check that this S dashed is an inertial frame or not an inertial frame. How we can check? If your aim is to know about the fact that S dashed is which type of frame, then you can easily check it, but only when you already know about some inertial frame. As you know, S is an inertial frame and S dashed is an unknown frame. Then to know that S dashed is either an inertial frame or a non-inertial frame, you must find the acceleration of the unknown frame with respect to the non-inertial frame. It means we will find a S dashed S. What does this symbol means? It means acceleration of S dashed with respect to S. And you have definitely studied in 11th level that AS dashed S is equal to AS dashed minus AS. AS dashed means acceleration of S dashed. Okay. And AS means acceleration of S. Okay. But we know that S is equal to S is an inertial frame. So if this acceleration of S dashed with respect to S is also 0, then you can say that this S dashed is also an inertial frame. In brief, you can say if acceleration of a frame with respect to with respect to an inertial frame is 0, then that frame is also an inertial frame. Here, the acceleration of S dashed is 0 with respect to the inertial frame S, then S dashed is also an inertial frame. But if acceleration of let us say S dashed with respect to the inertial frame S is not equal to 0, then S dashed will be not an inertial frame, it will be a non-inertial frame. Okay? It will be a non-inertial frame. So in this way, if we know about an inertial frame, we can easily check the another frame is inertial or not. We have only to find the acceleration of the unknown frame with respect to the non-inertial frame. If this acceleration is 0, the unknown frame is also an inertial frame. But if that acceleration is not 0, then the unknown frame is a non-inertial frame. Okay, I think you have clearly understand it. Now, after knowing the important facts or important properties of an inertial frame, I would like to explain this inertial frame in a mathematical way. And for this, let us consider that this S is an inertial frame. S is what? It is an inertial frame. Inertial frame. And you may take an example of it. Let us consider that there is a plant or there is a tree standing in your garden. Okay, and that tree is treated like a frame, and the name of that frame I have taken here S. So S, you can say this is a frame attached with a body which is stationary on ground level. A tree is stationary on ground level, and I have named it S. Okay, and this B is a body lying on the surface of the ground. Mark this word lying. It is not moving, it is lying. पड़ा हुआ है. Okay? And its mass is m. Now the observer O, you can think that at the origin there is an observer which is observing the motion of this body B. The body B of mass m is lying on the surface of the ground. Mark it. And this tree is standing on the surface of the ground. Okay? Now, this observer O has to decide that the frame S is an inertial frame or not an inertial frame. How he will decide? For this, let us see what forces will act on this body B. You know, the first force will be force of gravity, which is mg, and this mg is acting in downward direction. And the another force will be the normal force N, which acts on the body due to this surface on which the body is lying, and it acts in upward direction. So the body under consideration is acted upon by two forces. First one is weight of the body mg, or you can say force of gravity mg, and another is normal force or normal reaction, which is exerted on the body by this floor. So the net force acting on this body will be what? You know, when you want to find the resultant force or net force, you have to take actually the vector sum of the different forces acting on the body. So the resultant force, you can say, this will be, if it is F, then this will be vector N plus vector mg. But you can see the figure. Mg is acting downward, okay? And this N is acting in upward direction. So both of these forces are anti-parallel. So N is just in opposite direction of mg. And you know, when two vectors are in opposite direction, the magnitude of the resultant vector will be equal to difference of the magnitude of the two individual vectors. So resultant force will be equal to N difference mg. I have written here the sign of difference. You can also write minus sign. You may write N minus mg. But writing difference is more appropriate. Okay? Now, if you assume that this normal force and this force of gravity are equal, then F will be equal to 0. It means, in short, you can say that we have considered a body B lying on the surface of the ground on which resultant force is equal to 0. It means you have considered a force-free body. Okay? Now, we will calculate the acceleration of this body B with respect to this frame S, which I have considered associated with a tree standing on the surface of the ground. Okay? So let us try to find its acceleration with respect to that frame. If you write the acceleration of the body B with respect to S by the symbol ABS, then what will be this ABS? You know, this will be AB minus AS. What is this AB? When you write only one subscript, that means you are talking about the value of that quantity with respect to ground. This AB is actually equivalent to ABG. It means acceleration of B with respect to ground. But you know, you have considered that this body is lying on the surface of the ground. Since it is stationary on the surface of the ground, so definitely its acceleration with respect to ground is 0. Okay. Similarly, AS is what? AS means ASG. It means this is acceleration of S with respect to ground. And this tree or this S is standing on the surface of the ground. So this ASG will be also 0. So both AB and AS are 0. And so ABS will be 0 minus 0, that is 0. It means you can see that we have obtained that the acceleration of the body B with respect to the frame S is equal to 0. And you know, the body whose acceleration has been found to be zero with respect to s, that is a force-free body. We have already assumed that no force is acting or resultant force on the body is zero. So what happens in this frame S? What the observer of this frame S will observe? If you will ask the observer of frame S that your frame S is an inertial frame or not, he will say definitely my frame S is an inertial frame. Why? Why he will say like this? Because he will claim that I am observing that acceleration of a body on which net force is zero is also zero. And so Newton's first law of motion is holding. It is valid in this frame S because the event taking place in frame S is what? This event is like this: F is zero and then A is also zero. So you can say that in frame S, Newton's first law of motion is holding, it is valid, and if Newton's first law of motion is valid in this frame, according to the criteria, you can say that S is an inertial frame. I think we have clearly understand what is an inertial frame and how we can explain that a given frame is an inertial frame. Okay? Now we will explain the concept of non-inertial frame, which is actually the subject matter of our present series of lectures. Okay? In fact, when you say non-inertial frame, you can easily state all the conditions for non-inertial frame. And for this, what you have to do? Actually, you have to state all the conditions of inertial frame in reverse manner. It means what you have told in case of inertial frame, now you should say those statements in just opposite manner. Start from beginning. You have told that inertial frames are those frames in which Newton's first law of motion holds. When you talk about non-inertial frame, what you will say? You will say that non-inertial frames are those frames in which Newton's first law of motion does not hold. Okay? And when you say that Newton's first law of motion does not hold, what does it mean? Mathematically, you can say that even the force on the body is zero, even then acceleration of the body will be not zero. Because Newton's first law says when F is zero, then A must be zero. But if you say that Newton's first law of motion is not holding, it is not valid, then what will happen? Then there will be the condition that F is although zero. It means we will consider a force-free body. But when we will measure the acceleration of the body, that will be non-zero. So if you find acceleration of a body non-zero from a frame, with respect to a frame, although net force on the body is zero, then you must say that very frame is a non-inertial frame. Okay? In case of inertial frame, we have told that inertial frames are unaccelerated frame. Non-inertial frame में क्या बोलेंगे? These are accelerated frames. Okay? It means these non-inertial frames are frames which are in accelerated motion with respect to an inertial frame. It means all frames accelerating with respect to inertial frames are non-inertial frames. Okay? Now, we will explain this non-inertial frame just like you have explained the inertial frame. And for this, again see this figure. Now, we have considered here a vehicle. You can see this figure. This is a vehicle. And there is an observer standing on in this vehicle. Okay? There is an observer. And we consider a frame S dash attached with this vehicle. and this vehicle is moving with a constant acceleration, let us say a, with respect to this inertial frame S. Now S is an inertial frame, it is known, and the frame S dash, which is attached with this moving vehicle, uh, is unknown frame. It is we have to actually prove that this frame will be a non-inertial frame, and for this we consider that this frame S dash is moving with an acceleration a with respect to S. It means a is the acceleration of frame S dash with inertial frame S. Okay. Now again we consider the same body B, and you know on body B there are two forces acting, mg and n, and the resultant force on it is 0. You have already seen this. Now let us calculate the acceleration of this body B, which is actually force free body, with respect to this frame S dash. You have to calculate it. So let us see this figure. Acceleration of body B with respect to S dash. We have to calculate. What will be this? This will be AB minus AS dash. AB minus AS dash. Okay. But you know that this acceleration of the body B with respect to, yes, you know this AB is equal to 0 because this body is lying on this surface, okay, lying on this surface, and AB means acceleration of body B with respect to the ground. You have seen, with respect to the ground, and with respect to ground this body is at rest, so AB will be 0. And AS dash, this is acceleration of frame S dash with respect to ground or with respect to S, because S is already ground. And we have assumed that this is A, so AS dash is equal to A. And so you can say that acceleration of body B with respect to frame S dash is minus A, and so it is not equal to 0. What does it mean? It means if you will ask this observer in frame S dash that what is the acceleration of this body B with respect to your frame, his answer will be what? His answer will be that acceleration of this body is minus A. It means he will say that acceleration of body B is equal to acceleration of the vehicle A, but in opposite direction. If the vehicle is moving towards positive x-axis, the observer of this frame S dash will find that this body is moving with the same acceleration in negative x direction. So you can see that although the body is force free, it means no net force is acting on this body B, but in spite of that, acceleration of the body is not 0 with respect to S dash. So when you will ask the observer of this frame S dash that is Newton's first law of motion correct in your frame, is valid in your frame, his answer will be no. Newton's first law of motion is not valid in my frame, because his answer will be what? His answer will, or he will claim that I am observing that a body on which you are saying that net force is 0, I am saying that the acceleration of the body is not 0. Force on the body is 0, but acceleration is not 0. So definitely he will claim that Newton's first law of motion is not valid in this frame S dash. And since Newton's first law of motion is not valid in frame S dash, so according to the criteria, you can say that this S dash is a non-inertial frame. Okay, and I have actually mentioned all those facts here for your convenience. You can write down these things in your notebook, and that will be a very good notes for your examination. Okay, I have mentioned that that the net force on the body B acting is equal to 0. It means you have considered the force free body, and I have calculated the acceleration of body B with respect to S dash, which is AB minus S dash, and you have seen that AB, which is acceleration of body B with respect to the ground, that will be 0 because the body is lying on the ground. So it is not accelerated with respect to the ground. And S dash, this is acceleration of frame S dash, that is acceleration of the vehicle with respect to the ground, and that is equal to A. So this will be 0 minus A. That's why you can say that acceleration of body B with respect to frame S dash is minus A, which is not 0. So in frame S dash, what type of event takes place? What the observer of frame S dash observes? He observed that F is 0 on the body, but acceleration of the body is not 0. A is not equal to 0. So he will claim that Newton's first law of motion is not valid in the frame S dash, and so this frame is a non-inertial frame. Okay, so I think you have definitely learnt all the facts which I have discussed in this video, and after this we will learn about writing equation of motion in a non-inertial frame, and there you will find a very important concept of pseudo force or fictitious force. Okay, so wait for my second video on this subject. Okay, thank you.